Hi, so welcome to Chapter 9. We're going to be talking about integration. Now, we've been handling integration in terms of different families of functions so far. Now we're going to take a look at the operations which connect the functions. That's why we call it a more algebraic approach, because algebra is the concept of math which deals with the different operations. We're going to be doing this with integration by parts. You should have already read the section. I'm expecting you to have read the section. If you haven't read the section, stop and go read the section and complete the reading check. Make sure you get a 3 out of 3. You can do this as many times as you want. Now, I'm going to assume that you already have read the section. I think I've said that enough. I hope I have. And I'm just going to go right into how to use integration by parts, not why it works. All right, let's take a look at an example. So our aim today is how do we use integration by parts, and I've listed out the integration formula that you need up here at the top. If you have something that looks like this, integration by parts says you can rewrite it like this. Here are the steps. Choose u and a dv. dv has to just be everything else. So if you choose u, dv is what's left over. You compute the derivative of u, and you take the integral of dv. Last but not least, you apply the formula. Which one? This formula. Let's take a look. This is going to be our first example. So first things first, we want to find a u and a dv. So we're going to say u here is just going to equal to x. That's what we're choosing. Now I'm going to say that dv is just going to equal to sine of x. That's just everything else. This is our u, and then dx has to go here. This is everything else inside the integral. Your u and your dv have to occupy the entire integral. If something is left over and it's not in dv and u, you did something wrong. Next step, compute the derivative of u and find the integral of v. Well, we know what the derivative of this is. Du here is just, well, dx. Because the derivative of x is 1, and then we just need dx in case x was something weird. Well, I want to find what v is now. Well, whose derivative is sine of x? Well, that's going to be negative cosine of x. Because the derivative of negative cosine of x is sine of x dx. Notice, this does not have a differential at the end. This does, this does. Now, we're just going to plug into the formula. Formula says u times v, so we're going to have x times negative cosine of x minus the integral of v, that's going to be negative cosine of x, du. Well, du here is just dx. Cool. Let's move it up just to make sure we can see it. And we know what this integral is. That's just going to become sine of x plus c. That's because this derivative is negative cosine of x. All this is going to come down, so it's just negative x cosine of x minus sine of x plus c. That's integration by parts. The important thing to recognize is that integration by parts should always make your life easier. If it's making your life more difficult, something went wrong. For instance, if I said that u was equal to sine of x, and I said that dv is just equal to everything else, so x dx, because this would just be sine of x, this would be dv. Well, let's see what it would be. Well, du would just be cosine of x, and here v, well, that's going to be this. Okay, fractions don't necessarily make things more difficult, but it's maybe an indicator that it won't work out. Let's plug into our formula. So that's just going to end up being sine of x times x squared over 2. Okay, that looks annoying, but it's not necessarily the worst thing in the world. We want to see if our integral is easier. Well, our integral is not easier, because that gives us, oh, that needs a dx. That gives us this. In order to integrate this, we would need to use integration by parts again. And while it's entirely possible to do that, I'm not going to give that to you in the first lesson on this topic. So that was our first example. It's important what we choose u to be. If we chose u to be something else in that first example, we'd wind up with an integral which is much more complicated. We would actually need to use integration by parts a second time. That's not to say that there won't be times when you do use integration by parts twice. I'm just not going to do that to you in the beginning of the lesson. Let's take a look at two more examples, and we're going to see how choosing u first and making sure that it differentiates something easier makes your life easier. So we're going to do two more examples real quick with integration by parts. They're right here. You might want to pause the video and write them in. Now remember, you want u to differentiate something simpler. So here I'm going to say u is equal to x. That means that du is just equal to dx. That means that dv is everything else. Cosine of 5x dx. Well, if that's dv, then that's just going to be v. It has to have a 1/5 multiplying everything at the end by the chain rule. Well, let's just plug in, see what we get. All right, now we can simplify this a little bit. We can pull this 1/5 out. All this can just come on down. So I'm going to combine the x and the 5th. And then we can integrate this easy enough. It's going to be really similar to what we've seen in the past. This 1/5 is going to come down. This is going to become a negative cosine of 5x. We need to undo this again, so it's still that. It's going to be plus c. This just comes on down. Don't forget to bring it down. It's really easy to forget to bring it down. Then this 1/5 times that 1/5 is going to be 1/25. That negative and that negative is just going to be a positive. And then we have cosine of 5x plus c. We're done with that one. Let's take a look at the second one. So here again, we're choosing u to make things easier. So that means du is just going to be dx. And then dv is just everything else. It's easier if you choose u first. Okay, so that means here, well, that's really special. So, boom. Then, we're just going to do the exact same thing that we've done before. Now our integral is a lot easier. Before you start integrating, take this negative out. Gonna make your life easier. So that's just gonna come on down. Let me simplify that side real fast. Plus e to the negative x dx. But we know what the integral of e to the negative x is. It's just negative e to the negative x plus c. And we're done. All right, so you've seen 3 examples. Give the classwork a shot. The classwork are all the odd-numbered problems that are listed there. And the reason they're the classwork is it gives you the answer, so you can check the answer. Remember, if you wind up with something different or strange, check out what you chose to be you. You're going to submit that as one assignment. Then, you're going to submit the even ones as a homework assignment. That's going to be your second assignment. All right? Please make sure you're following the agenda. And you only have 2 days to do this. Do not think you have until Friday. You don't. I've adjusted based on the 11th and 12th grade schedules. Stay safe, folks. If you have any questions, see me during office hours. And I'll talk at you soon.